Today we're going to be working on 12.5, which is multiplying and dividing rational expressions. So earlier we worked on just simplifying rational expressions and finding out what the excluded values were. Now we're going to start multiplying them together, and we're going to need to still simplify our answer in the end, and we have to check for excluded values as well. So that excluded values part has not gone away at all. The first problem that we're going to work on is just multiplying monomials together. I'll give you a moment to jot down this monomial. In regards to the monomials that we have up here, you have basically two fractions being multiplied together. And we are going to cancel between numerator and denominator any factors that we can, just like normal fractions. So think of this, please, as one big fraction where things are being multiplied together, numerator and denominator. So when you start looking at being able to cancel, perhaps you could do one of two things. One, you could go ahead and multiply these together and have 30. And what would the y's be? Y to the third times y to the third is y to the 6. Okay. Over in the denominator, 5 times 8, 40, and the y's would give you y to the 6, okay? So you could multiply things together and then look at the remaining fraction and simplify from there. What would this look like simplified, please? Michael Johnson? 3/4. Okay. The y to the 6 would cancel each other out. We'd take 10 out of each of the 30 and the 40. That's one way to go about doing it. Another way, looking at it a different direction here, is to start canceling between numerator and denominator. I know that 2 goes into 8 4 times. I know that 5 goes into 15 3 times. I've got a y cancels with one of the y's up here. Okay, I got, in the essence, 5 y's up here. These are all gone with all the y's down there. What does it look like? A mess. Okay, it looks kind of like a mess, doesn't it? It's kind of hard to read through. You decide what you're going to do. This might be too messy for some of you to read through and come up with an answer of 3/4. This one looks much neater, easier to see what's going on, but not always do you have to combine everything together to be able to cancel. Because sometimes the numbers get kind of big on us, and then you just have to divide them out again anyway. So use your common sense in regards to what you're going to do. Sometimes you can just cancel between numerator and denominator and be done, and then multiply what you have left. Sometimes it's good to multiply them together and then cancel when everything's kind of simplified in that way. Any questions there so far? Why don't you work on this one, please? And we'll have some people come up to the board. All right, looks like we have z over 8 on all of these. When we were starting this one, Megan here multiplied everything together so that she can cancel things and come up with z over 8. If you wanted, you have that z, that 7 into the 14 2 times. This z to the third, that z to the third is gone. You can cancel some things for yourself ahead of time if you wanted, and then you'd be able to finish up with this problem in the same manner. Any troubles there? Remember, we're canceling factors. We don't cancel something that's part of an addition or a subtraction expression. Binomial factors, we have to cancel the entire binomial factor. I have one more here. I'll do this one. Have some more people up to the board, please. All right, taking a look at this, if you, all you do is scratch everything out, it's really hard to look back at it and see what you did and give you any partial credit in case you get something wrong. So just for peace of mind, you might want to show me what's going on there. 4x to the third all over 5 is the correct answer here. Any questions in regards to this? You like these so far? All right. Now let's multiply some rational expressions involving polynomials. I upped it a couple notches, didn't I? Just a couple. Okay. Oh, you know what? Go ahead and write this down, and then we're going to go back a couple slides for just a moment because we forgot something. Yeah, so just jot down this, and we'll go back a couple slides for just a moment. All right, let's go back to, this was our first one, right? Yeah. We forgot to mention what y cannot be equal to.
Zero.
Oh, in this case, you're looking down here, you're saying, okay, it's 0. How about this one? What can z not be equal to? Look at your denominator. 0 also, because we have all these z's down here. There's no addition or subtraction going on, it's all just multiplication. Okay, on this one,
0.
What can x not be equal to?
0.
Okay, y'all agree with Angela? Okay. Then, now we get to this one, and we need to do some factoring. Okay, you wrote this one down already. I want you to feel free to take some time, perhaps with your partner even, and you need to factor every numerator and every denominator up there. All right? So feel free to get started. Back to the front, please. Up here we have our factors for the trinomials. Each trinomial, if it can be factored, you need to write it as binomial factors as well as a GCF if that's in there. Okay, so I would not recommend at this point multiplying all those together and trying to factor it at the end and divide. This is where crossing things out would be appropriate. Not scratch out, just cross out. So I'm going to pick up a different color pen than what John used up here and start looking between my numerator and my denominator for monomial factors that I can cancel and binomial factors that I can cancel. Please note, you cannot cancel something like an x squared and an x squared because there is more to that expression. So you just can't cancel part of an expression, which I know I've seen in the past from many people. But we can cancel some binomial factors, you know, an x plus something with that same one in the denominator. What do you see as a binomial factor that we can take care of, Melissa?
X plus 2.
Alrighty, so we've got this x plus 2 and this x plus 2. One mark through those is more than appropriate. Trenton, what do you see? An x minus 1 and an x minus 1. Okay, those are gone. Anything else that you see we can cancel? Eileen?
The x and the x.
Okay, we've got a monomial here, an x with an x. The 2 is not part of the x. Okay, if that was x to the second power, then we'd have a deal going on. But this 2 is all by itself. So then we come over here and we say, I have a 2 left. I have an x plus 1 left. All over in the denominator, I have a 5 and an x minus 2. When you're done writing your answer over on the right-hand side here, you should have no factors in common between the numerator and the denominator. These x's do not get to cancel. They are part of an expression. They are part of that binomial, so they stay there. The 2's do not cancel. This 2 on the bottom is with the x as an x minus 2. So we have here our simplified expression. We also have to state what x cannot be equal to. In order to determine that, you need to look back at the factors that you had in the denominator to begin with. What is one of those, Charlie?
0.
0 is one of them. Give me another, please. Melissa?
1.
1 is one of them. Give me another. Angela?
Plus or minus 2.
Okay, that's 2 others. All right, so plus and minus 2. That should take care of all of them. In this case, we have 4 different numbers that are excluded values for x. Do not multiply all that back out. Leave it in factored form. Okay. Any questions there so far? Nope. Fabulous. Okay, you do this one. Looking back at this now, we can see that x minus 4 over x plus 3 and x minus 2 is the simplified version. We're gonna leave that factored form. I don't want you to multiply it. Please don't multiply it back out, okay? And then having looked at the original numbers here, x plus 3, we had that up there twice, but we only have to write a -3 once. Our x plus 2 and our x minus 2 here, we have that plus minus 2 as our excluded values as well. Any questions in regards to this? Don, or Sean, excuse me, Trenton, I apologize.
So I had like, after I did the top, practice top right one, I had x plus 3 and x minus 4.
Yes,
And I canceled that with like, I had two x3s on the bottom.
yes.
Or one was plus 3 and one was minus 3.
On the bottom left-hand side, you had a plus 3 and a minus 3? So are you talking about this, triangle
I
over here?
put the plus on. Okay, I see what I did wrong. Never mind.
Are we okay?
I'm all good.
Anybody else? All right, let's go on then, please. Here I have 2w squared over w minus 7w plus 12, all times w minus 4. Where's that w minus 4 sitting? Numerator or denominator? Awesome. So when you're looking at this, think of that as over 1. Go ahead and do some factoring, please. All right, let's come back to this problem, please, here. We have 2w squared all over w minus 3 as our final answer, and we have that x cannot equal 3 or 4. Any troubles with this at all? Looking at everybody set around the board, everything looks all right on those. Well, let's keep moving on then.
Wait, this is gonna be
Quiz? No, not today. I'm going to skip over this one unless you want this one.
No.
Thank you very much. Because we have to also divide. Raise your hand, please. What is the rule for division of fractions? Mr. Jeffrey?
Multiply by the reciprocal.
Of the fraction that follows the division sign. Yeah. Please don't take the reciprocal of the first fraction. So when you're writing this, go ahead and write the problem down as is. But then you need to rewrite as a multiplication problem. And I would do that probably when I'm factoring. Okay. Meaning, okay, I've got my problem here. And then when I start factoring my numerator, where would I write my factors for the numerator of the second fraction? In the denominator. And I'd write the factors of my denominator in the numerator so that I flipped that fraction. Okay, does that make sense to you? All right. So go ahead and start working on this one, please. Up here we have multiplied by the reciprocal of the fraction that follows the division sign. So what we've now done is made it into a multiplication problem, which we've been working on all morning. So the division are no different than the multiplication, except you got to change the division into multiplication. This one had a lot of factors that canceled out, and we were left with x minus 4 over 4x. Please note you had to look back at your factors to determine that x is not 0, it's not -2, and it cannot be a plus minus 3. And those all come back from the original factors here. We did have a monomial factor, x, down there. That 4 times x is the monomial factor. Any questions there? Do we need another division one?
No.
I didn't think so. You guys are doing good. How about this one?
No.
Let me ask, though, about this one. How would you rewrite it as a multiplication problem? Andrea?
Write it times 1 over x plus 2.
Times 1 over x plus 2. Okay, so please be careful on something like that. John?
So whenever you have a monomial, it's always going to have the x equals, or n equals 0, right?
If you have just an x term not being added, subtracted to anything, yes, it's going to just be 0. Think about setting that equal to 0 and solving it. Okay. Anybody else there? All right. And this one, what would it be in the end? How would we rewrite it? Please, how would we be rewriting it? Charlie?
Times 1 over n minus 3.
Times 1 over n minus 3. And you guys could do that without a problem. Right now, what you need to work on, obviously, is factoring and being able to tell what the excluded values are, okay? I think we're ready for our quiz.